So in this video, we're going to continue your troubleshooting efforts once again, assuming several things, assuming that in the network, you are now the network administrator, and it's your job to get onto the default gateway that the employees are using to get to the outside world, get onto that router, and check to see if the problems they're having is related to that router or related to something else that's beyond that router. Maybe another router further upstream in the corporate network, maybe a router in the ISP's network, who knows? But we need to isolate that. Is it on the default gateway or is it not on the default gateway? So what have we looked at so far? Well, number one, we've made sure that you can actually get into the default gateway, and we've talked about how if the default gateway is frozen, what that could mean, or if the default gateway is not accepting your username and password, what that could mean. And then we said, okay, let's assume that's not a problem. You're able to get into the default gateway. Step number two was check the interfaces. Look at the interface leading downstream to the employees, the interface leading upstream towards the internet. Make sure those interfaces are actually functional. Make sure they're up. And if they're not, what are some things we could look for that might cause that problem? Now, also another assumption is, as the network administrator, we're assuming that you are the only person who's authorized to get into this router, that nobody else should be able to get into it to change it or do anything else. If you go in there and you see that there's been some change to the configuration, you can assume this thing's been hacked. Somebody has gotten into this router who was not supposed to be there, and they've changed it in some way. So those are the assumptions that we're going to be making. So now let's continue on. Once again, we've got employees who are saying, hey, I can't get to a particular website. So we've already checked that we can get into the default router, the default gateway, so that's done. We've already checked that the interfaces are up. That's good. So now the next thing to check is, does this router actually itself have routes to the internet? If a packet comes into the router from somebody's laptop or something, an employee, and that packet is going to a network that the router is not connected to, does the router know how to forward that packet on its way? So we're going to be looking now for lost routes. So, do we have routes for internet access? And if the answer is no, then we have to troubleshoot that. Identifying. Okay, so in order for your router to have routes for internet access, it basically falls into two different categories. There are some routers, which are, big, beefy routers with a lot of memory and a lot of CPU, and for whatever reason, the company has decided, I want this router to actually learn about everything that's out there. Now, as I record this in January of 2016, there's somewhere around 500,000 routes in the internet, which would be a massive routing table. But for example, if your router is actually owned by the ISP, if you go onto a router owned by Sprint or Comcast or Time Warner Cable, they probably have that. Their routers are huge, and they have huge routing tables of hundreds of thousands of routes. So that's one way to give you internet access, is that your router literally knows where everything is. But most routers fall into the second category, which is that they say, okay, most routers say, all right, well, I've only got one way out. I've got this one interface. Let's look at the whiteboard here for a second. So in my particular case, this default gateway says I've got one interface leading downstream to the employees, which is fast Ethernet 00, and I got one other interface leading upstream to the ISP, which is serial 010. So a lot of people would say, hey, look, since you've only got one way out anyway, why not just insert into this router something called a default route? And a default route typically takes the form of this, 0000. This means anything you don't know about, follow this. And then that route with a mask of /0, the next hop would be whatever this green router is right here. I'll just say ISP router. So in human terminology, think of it this way. When you want to write a letter, do you know all the people you're going to write letters to in your entire lifetime? No, you don't, right? You don't even know if you're going to be around tomorrow, much less the next 40 years. So you can't predict every single address you're ever going to want to write a letter to in the next, how many years you have left to live. But it's probably going to be a lot. So Do you know right now the actual street address and the path to get to that street address for anyone you're ever going to want to write to? Probably not, unless you got a crystal ball, in which case I need to meet you. So you don't know the location of where everybody lives in the entire world, but guess what? You don't have to. You know of a default route, which is what? The post office, right? You know that if you write a letter and you put an address on there and you put it in your mailbox, you can wipe your hands and walk away. You don't have to concern yourself with, okay, once this letter is picked up, it's going to go down First Street, get on an airplane, travel 5,000 miles to the Ukraine, then get off on this street. You don't have to know all that. All you have to know is, if I want to get a letter to any location that I actually myself don't know how to reach, I don't know how to physically get there, all I got to do is put in the post box, and the post office will pick it up, and it's their job to forward it on its way. So in your mind, that's your default route. Anything I don't know where it is, just put in the post office. As long as I have an address on there, the post office will know how to get it there. So most routers, in order to reach the internet, they know something similar. They've got a default route that says, hey, look, if I get a packet going to a location where I don't know how to get there, I'll just look for a route that looks like this, 0000. And if I've got that, I can just forward it to the next router up the chain, and hopefully he will know how to get there. So in my lab here, this is how we're going to be troubleshooting this. So I've got my laptop connected to a switch, connected to a router. And then that router is connected to the internet. So it's connected to some other router, and then I've got 3 devices in the internet here. I've got a server which is acting as a DNS server, 3.3.3.3, and I've got 2 websites I want to reach. www.r2.com and www.r4.com. So maybe the laptop is saying that the employee is saying, hey, look, I can get to r2.com, but I can't get to r4.com. In other words, we go onto our browser. So here I am as the employee. And I go to www.r2.com. And let's see if I can reach that. Okay, this is actually even better because it looks like r2.com is not coming up. Okay, so we talked about what were some of the troubleshooting steps here in the previous videos. We said, okay, number 1, r2.com, web page not available, connection timed out. Click on details. Connection may be down, or you may be experiencing issues with your internet connection. Okay, so we said number 1, do I actually have DNS resolution for r2.com? And so we brought up our command prompt, and we just did ns lookup r2.com. ns lookup www.r2.com. Okay, I'm sorry, I'm a little perplexed here because, and this is what happens when you've got both a wired and a Wi-Fi connection going at the same time. I'm using my Wi-Fi connection on my laptop, which is actually giving me my real internet connectivity, so that people in the live audience who are watching the class right now, I can actually see their questions as they come in. But what I wanted to do was, my initial problem was, okay, when I'm actually trying to get to these devices, these are actually sitting right here next to me. And so when I typed in r2.com or r4.com, I did not want to use my real internet DNS server, because these don't exist in the internet. They're right next to me. So I wanted to actually use my local DNS server here. And so what I did this morning was I went into my hosts file. And we actually talked about this on one of the videos, how when DNS resolution comes up, when you bring up your browser and you say, I want to go to google.com or cnn.com, we said, well, what happens is you send a DNS request, domain name service, to a DNS server. And you say, hey, DNS server, what's the actual IP address of google.com? And then if the DNS server exists and he is able to reply to you, he sends a response back saying, oh, google.com, here's the IP address, 199.5.whatever. And so now you've got this IP address. And what happens in your laptop, and I'm sure this also happens in smartphones and tablets as well, is it caches that response. In other words, it says, okay, I'm going to remember this, so that every time I go to google.com, I don't have to constantly pester that guy with requests. Now that he's answered me, I'm going to remember that for a period of time, and then I'll forget it. And that goes into something in Windows 7 at least, in something called the hosts file. The host file has all those cached entries. And what I did this morning was I said, well, I want to go into that host file and put in some static entries. In other words, when I bring up my browser and I go to r2.com or r4.com, I don't want it actually going to the DNS server because those devices are not out there on the internet. They're right here next to me. So I went into the host file and I put in some static entries for these two locations. I put in these names and then their actual IP addresses. But this is where I'm getting a little bit stumped now, because as I'm doing NS lookup, which actually what's coming to me now is I'd have to do a little bit of research on this. And maybe those of you in the live audience, you can answer this question, but I'm starting to think that maybe when you do NS lookup, it completely bypasses whatever static configuration you may have and says, okay, I'm going to forcefully do a DNS lookup just to see if I get anything back. I might not actually use that. If I've got a static entry, I'm going to prefer the static entry, but possibly NS lookup. I think that's what's happening here, is this is forcing a DNS resolution. So let's check my hosts file. Make sure my host file actually still exists. So how do you check your host file, in case you're curious about this? Well, first thing is you're going to open up some text editor, and I'm just going to open up Notepad. And now this is just for Windows 7. This particular path probably won't be the same for Windows 8 and Windows 10, but in Windows 7, you go Open, and then you go to your C drive, and then you go into Windows, and then sort it by name. Oh, no, I don't want new folder. Wrong. Get rid of that. I want to sort it by name. Okay, and then you want to go into drivers. No, System 32. System 32, where are you? There it is. So C:\Windows System 32. And once you get in here, you want to go into drivers, right there. And then you want to go into etc. And I'm not looking for text documents, I'm just looking for files. And there's my hosts file right there. And this is the file I modified just about an hour ago by putting in a couple static entries. Yeah, see, there they are. So these are two static entries I put into my host file before I started the show today. I said, okay, if you ever want to go to r2.com, I'm telling you, the IP address is 2.2.2.2. Don't bother looking it up via DNS. I'm already giving you the entry. So my host file here is correct. That is what I typed in earlier. So let's do a little bit of troubleshooting now. Okay, so my laptop, he knows. When I type in r2.com or www.r2.com, I don't have to do DNS. I know that the IP address is 2222. So now, the next thing is, does my laptop know how to get to that network, 2222? And we looked at that in a previous video. We said, well, the way you would do that is, once again, open up your DOS prompt. Here it is. And use the route print command. That shows you all the networks that your laptop actually knows about. So let's scroll up here. Okay, and this is also something I did earlier before class. I said, okay, look at the top one. That's my default route. That says anything I don't know about, go to the router of 10711. Now this is actually my real default gateway here at INE. That's a real router that can give me access to you guys and the live stream and any other real website I want to get to. But earlier before the show, I put in some static routes. For example, the 222 network right there, the, what is that, the fifth entry down. I manually put that in there saying if you want to get to anything beginning with 222, go to this other router, which is 1.1.1.1. And that router right there, that's actually this router, this default gateway. So let's just put his address there. That's him. Okay, so we're still trying to troubleshoot. Why can't this laptop bring up the website of R2? We know that when I type in www.r2.com, we know the laptop has a static entry saying, okay, I know who that is. That is the IP address of 2.2.2.2. Then he goes and he says, well, how do I get there? He says, oh, I've got a static route. That route tells me to get to anything beginning with 222, go to this guy, 1111. So that should be all the laptop needs. The laptop is now generating his HTTP packet and saying, hey, I need the website of 2222, which corresponds to the name of r2.com, and he's sending that request to the default gateway. So now let's check the default gateway. Once he gets that packet, does he know what to do with it? So here we are on the default gateway. First thing we want to check is show IP route. Okay, he is directly connected, it says right here. So any packet he gets going to 2.2.2.anything, he actually lives in that room. He's connected to that room on this particular cable called a serial interface, serial 010. Now, can he ping that address? Okay, he's able to ping it. So at this point, can my laptop ping it? Let's check. This is another thing we checked in a previous video. Now that we know that DNS has worked, can I actually ping the website? Ah, I cannot ping it. Okay, so why can the router ping it, but the laptop can't? Let's go back to our drawing of what our topology looks like. So 2222 is this guy right here. Now, in reality, the way I've got this actually set up in my lab is that this router right here is 2222, R2. So my default gateway is directly connected to it because we saw he was directly connected. So 2.2.2.2. So we know that the router 1, he's just fine. He can ping it. When I tried pinging 2222, he got a response back. But when I tried pinging that from the PC, he did not get a response back. Now here's what I'm suspecting. We know the PC knows to give that packet to R1. We further know, we've proved that when R1 receives a packet going to 2222 as the destination, he knows where to send it because he's directly connected. So my suspicion is this. When this router was directly pinging 2222, remember, in order for a ping to work, not only do we need a destination address, we also need a source address, right? Because as I'm sending it, the person who's going to reply is going to use my source address to reply back to that source. Well, when this default gateway did his ping to 2222, he said, okay, well, I'm a router. I've got more than one IP address. He said, I've got the IP address over here on my fast Ethernet of 1111, and I've got the IP address here on my serial of 2221. He says, okay, I'm pinging 2222. Which interface am I going to use for that? Oh, I'm directly connected to that on serial 010. So why don't I just use that IP address as my source IP address? So when this default gateway did his ping to website number 1, which is 2222, as his source IP address, he used 2221. Well, that was easy for R2 to reply to because R2 said, hey, I'm directly connected to the 222 network. So if someone's pinging me and his source address is 22221, I can reply right back to that because we're both exactly on the same cable. We live on the same cable. But that was not the case when this laptop is pinging. When this laptop did his ping, he sourced it from 111 something. Let's find out. What's the source address of the laptop? ipconfig. That came from my wired Ethernet interface, which is 1113. Now he doesn't have a default gateway here, but he shouldn't need one because I gave him a static route. Let's just check real quickly. So here's the next question. He has a static route. This field is a little troublesome because usually the default gateway is populated with something. So now the next thing that's sort of percolating in my mind is we have two possible problems here. Either my laptop, because he doesn't have a default gateway, he ignored the static route. And he said, okay, even though I know how to get to the 222 network, I'm going to ignore it. And he just didn't even bother to ping it. I don't think that's what happened, but we can test that in a second. Or the other possibility is that when the packet actually was received on R2, he saw a packet coming in from 1.1.1. something, and maybe he said, I don't know where that is. I'm not directly connected to the 111 network. How do I reply to this thing? So let's go on to this router R2 and actually see if he's got a route back to the 111 network. That's easier to troubleshoot than troubleshooting to see if this laptop actually even sent the packet in the first place. So let's go to R2 and see if he has a route for the 111 network. Show IP route. And here's the source of our problem. So my upstream router, which in this case, going back to our original topology, where is that? In this particular case, the problem is not that we can't get to the website, but that the website can't reply back to us because the internet doesn't know where this 111 network actually lives. This is actually something we're going to cover in a subsequent video, but we'll just cover it now. So let's go ahead and fix that. So he doesn't know about the 111 network, so that's probably the fault of the default gateway. My default gateway is probably not advertising that route like he should. Let's find out here. Well, he is advertising it. Network 1, show IP protocol. Okay, so here under EIGRP, which is my routing protocol I'm using with my ISP, under routing for networks, that says what networks is my router actually routing on? And these should also be networks that he's advertising upstream. And he says the 1 network. Alrighty. So some of you guys might be thinking, wait a second, it said passive interface. Passive interface will not affect this situation. In this particular case, just because I've made this passive, this router should still be able to pick up this network and advertise it upstream to this guy. So now we got a bit of a dilemma here. So the routing protocol is correctly configured to pick up this network and advertise it to his ISP. So why doesn't the ISP know about the 111 network? All right, so now we got to get a little bit deeper into our EIGRP troubleshooting here. Next thing I would check is, okay, if he really is, if my router, my default gateway, if he really is advertising that via EIGRP, in his EIGRP topology table, I should see that network, that directly connected network. And I do. So here it is. The fact that's in here and the fact that's right here under this section, that gives me the proof that I need that he actually is advertising that network. Furthermore, if I go back to my running config, I don't see any weird stuff here. So there's nothing in my outbound interface. So this is the interface to the internet. You might be thinking, well, is there some weird command in there or something that would prevent him from advertising that network? Nope. There's just simply an IP address. That's it. No weird command in here. So let's go back to router R2. Show IP route. I'm sure he still doesn't have it. Doesn't have the 1 network. Wait a second. Okay. Well, this is for outbound. That should not affect it. So what does his topology table look like? He has not learned of that. Show IP EIGRP neighbor. Well, of course we have a neighbor. Well, wait a second. Something's wrong there. He should have 2 neighbors. Okay. Okay, so here's the issue. There is no EIGRP neighbor relationship between these 2 routers. And so because they never talked to each other, they never exchanged routes. And I know why that is the case. That is because on my default gateway, this right here is the interface leading upstream to my ISP router. But in my EIGRP configuration, I said, make that interface passive. And when you make an interface passive, that basically says, don't talk. on that interface. Don't talk routing protocols. So whatever EIGRP needs to form a neighbor relationship, don't do it here. And so that caused my neighbor relationship to fail. So router EIGRP 100, let's remove this because I actually do want him to speak EIGRP. All right, so now let's go back. Let's go back to my laptop. www.r2.com, and now I can reach it. And if I look in my routing table, I'm still directly connected to it, but the change that has happened now is now when I go to the upstream router, R2, and I look at his routing table, so now where am I in the topology? Now I'm on this router right here. I've gone to this guy. Now when I look in his routing table, he has now learned about the network where my laptop lives. And so he can respond to ping packets and HTTP web browsing packets. He can reply to those packets because he knows where to forward those replies. So let's go back to where we were. Our initial problem, what we were trying to diagnose was if a laptop was unable to reach the internet, made sure we could access the default gateway, verified that the relevant interfaces were functional and up, and then we checked to see did he have routes to reach the internet. So let's go back to that router, show IP route, and now we can see he does have a route to reach the internet. 0.0.0.0 will tell him anything you don't know how to get to, forward it to this router, your neighbor 2222. So now when I go into my laptop and I type www.r4.com, now remember, I statically configured my laptop to know that R4 is the IP address of 4.4.4.4.4. When he forwards a packet, I should say when he generates a packet going to a destination of 4.4.4.4 and he sends it to his default gateway is going to say, well, I don't have any specific knowledge of that network. I don't really know where 4.4.4. anything lives. But I do have this sort of catch-all route. And so when you send me a packet to 4.4 or 90.5 or 130.20 or anything that I don't know about here, I will forward that packet to my neighbor of 2222. And so let's see if r4.com works. Yep, see, it looks the same, but notice how this just changed to R4. Looks like the same website, but it's actually different. So let's summarize here. Go onto the default gateway. Does he actually have a route outbound? Does he know how to get to the internet? And we identified that by just basically doing show IP route. Now, if the answer was no, if he didn't, how did we troubleshoot that? Well, first of all, we checked to see if we had a neighbor relationship. Because if you're going to learn about a route to the internet, you have to have a routing protocol neighbor relationship. Now, that just depends on if you're doing EIGRP or OSPF or BGP. But whatever routing protocol you're using, you have to form that relationship with your upstream router so you guys can talk to each other and exchange the knowledge that you have. Then we could also do a show run. Now these were not in this lab here, but we could look for unexpected distribute lists. So a distribute list, I'm just going to do a real high level snapshot of that, is basically a way of going into a routing protocol, and we can use a distribute list for one of two things. Let's say my router knows about 25 routes. Okay, so let's say I'm a router, you're a router, and we're connected. We're talking to each other. We're neighbors. I learn about 25 routes back here behind me. Normally, I would advertise those to you. I would say, hey neighbor, here's 25 networks I've learned about. You can use me to get to them. A distribute list is a way of saying, well, as a network administrator, I don't want this router to forward all 25 routes to you. I only want to forward maybe 3 of those routes to you and then suppress or hold back the remaining 22 of those routes. So I could configure a distribute list to say, okay, I'm only going to advertise these 3 routes to you. The rest of them, I'm going to keep to myself. That's called an outbound distribute list. It's controlling what I'm sending outbound to you. Or conversely, I could use something called an inbound distribute list. Maybe I say on my router, well, I don't know what you are going to send to me. I don't know how many routes you're going to send to me, but what I do know is the only route I am really interested in is the 90 network. That's all I need to know how to get to. So if you send me anything other than the 90 network, I don't want that. So I could configure an inbound distribute list saying, okay, I'm only going to allow you to send me the 90 network. If you send me anything else, I'm going to ignore that. I'm going to discard that. So that could have been our problem here. Maybe somebody hacked into my default gateway and they configured some sort of weird inbound distribute list that canceled out that default route. So even though the ISP was advertising the default route, maybe some distribute list said, nope, I'm not going to look at that. I'm going to ignore that. And so that ended up with a loss of connectivity. We no longer had that route in our routing table. We couldn't reach it. There could also be some unexpected route maps. So route maps can also accomplish the same type of thing as distribute lists. Now route maps can go do a lot more as well, but I could use a route map for the same purpose. Control what I send outbound to my neighbor or control what I'm allowed to receive inbound from that neighbor. So once again, if somebody hacked into my router, it's possible that trying to be sneaky, they added or changed some distribute lists or route maps, which caused my router to now lose his internet routes. Now, if that's not the case, if I go into my router, show IP route, I say, where's my internet route? I don't see it. It was in here. And I say, okay, I'm the only one who's supposed to control this router. I'm the master of this router. Nobody else should be getting in here and changing it. I said, okay, let me look and see if anybody's hacked into this guy and made any changes. So first of all, I looked at my neighbor relationships. Still got my neighbor relationships. That's there. Okay, so I'm still talking to this router, my ISP router. Then I looked at my show run. I said, is there anything in my running config here that would explain why I'm missing my routes? And I said, I don't see anything. Don't see any distribute lists. Don't see any route maps. Don't see anything on my router that would account for the fact that my router is the one who's at fault. My router is the one who's dropping the information. So if I've ruled all that out, now I got to call up my ISP, the upstream device. Now I got to say, hey, can you check your router because I'm not receiving internet routes from you. And maybe they did something on their end that they didn't tell me about, which is causing me to lose my routes. Now, my particular walkthrough here, it actually was my problem. And in this particular case, when I did show IP EIGRP neighbor, this first command, I realized, oh, I don't have a neighbor. I'm not talking to that neighbor. And it turned out that somebody had hacked into my router. It was really me before the class, but we assumed somebody had hacked into the router and used the passive interface command to basically prevent my interface going to the ISP from talking and saying, okay, I'm not even going to speak routing protocol with that interface. And so that's what caused me to lose my routes.